Hi everyone, today we're going to talk about exponential decay, which is the second part of section 9-3. We talked about exponential growth in our last lesson, which is when a quantity increases by the same rate in each time period. Exponential decay is the opposite of that. Exponential decay is when a quantity decreases by the same rate, which is represented by the variable r, in each time period, which is represented by the variable t. Exponential decay is a function that has the form of y equals a times the quantity 1 minus r to the t power, where a is greater than 0. The difference between exponential growth and exponential decay, if you look, exponential growth had a plus sign in the formula, whereas exponential decay has a minus sign. Y still represents the final amount. A still represents your original or starting amount. R is still the rate of decay in decimal form. So if something is decreasing at a 6% rate, it would be 0.06. And T is represented by time. Let's look at an example together. It says the population of a town is decreasing at a rate of 1% per year. In 2000, there were 1,300 people. Write an exponential decay function to model the situation, then find the population in 2008. So again, this is a two-step problem. The first thing you're going to do is write the function, and then we're going to use that function to find the population in 2008. So we're going to start with A equals, and then again, it's always your starting amount or your initial amount, which in this case is 1,300. And now for this formula, it's going to be the percent written as a decimal, which would be 0.01, but you're subtracting that from 1 instead of adding it to 1. And it's to the t power. Again, if we were answering this first part, write the exponential decay function. This is what the function looks like. We leave the variable t in the function, and then we can use this function to figure out the population after any amount of years. The question is to find the population after from 2000 to 2008. So from 2000 to 2008, 8 years have passed. So when we fill in this function, we're going to subtract 1 minus 0.01, which would be 0.99, and then we're going to raise that to the 8th power. You can always use a calculator, a scientific or a graphing calculator. If you don't have a calculator like that, then you would have to do the order of operations yourself. So 0.99 raised to the 8th power, and then multiply that by 1,300. And when you work that out, you should end up with approximately 1,200. So because we're talking about a population and the number of people, we round to the nearest whole number, which would be 1,200. So after 8 years, the population that started at 1,300 would be approximately 1,200. A half-life is another common use of exponential decay. A half-life talks about a chemical compound, and it literally is called half-life because the rate of decay is 50% or 0.5. So a half-life, the function is written as capital A equals capital P times 0.5 raised to the t power. A is again the final amount, and capital P is your starting amount or your original amount, and T is the number of half-lives given in a time period. And this is the key part of a half-life. If the problem will say to you, look, the half-life of the compound is 5 days, and then they're going to say, figure out how much is left after 25 days. Because the half-life was 5 days, that does not mean, or we're not looking at 25 days as your t. Since the half-life is 5 days, that means 5 lives take place in those 25 days. So again, I'll just type it out, it'll be faster. If, for example, the half-life is 5 days, in 25 days, there would be 5 half-lives. In 50 days, if it was a 5-day half-life, there would be 10 half-lives that take place. So the big part about a half-life is that you first figure out what your t is equal to. It's not the given number of days or seconds or minutes or hours. It's how many times a half-life occurs within that time period. Let's do 2 examples of half-lives because they're a little bit more complicated. This says here that fluorine-20 has a half-life of 11 seconds. The first question says, find the amount of fluorine-20 left from a 40-gram sample after 44 seconds. So again, my time period is 44 seconds. That is not the T that I'm going to use in the formula, though. The formula, they're saying fluorine-20 has a half-life of 11 seconds. So the first thing you need to do is figure out how many times 11 seconds occurs in 44 seconds. And hopefully we all realize that 44 divided by 11 would give me 4. So that means that my T is actually equal to 4 in this problem. When I write out the formula, again, it is A equals the starting amount, which in this case is a 40-gram sample, so 40. Let me just highlight that for you. The starting amount, again, is 40. The number in parentheses for a half-life is always 0.5, or you could use the fraction 1/2 because it's a half-life. And then again, we said that 44 divided by 11 is equal to 4, so my T value is 4. And when we work this out, you're just going to do 0.5 to the 4th power times 40, which is 2.5 grams. So that means that if you have a fluorine-20 sample that's 40 grams, after just 45 seconds, it has decreased to 2.5 grams. Okay, let's try one more example. It says find the amount of fluorine-20 left from a 40-gram sample after 2.2 minutes. Round your answer to the nearest hundredth. So the first thing we're going to do is figure out how many half-lives occur in 2.2 minutes. They gave us the half-life in 11 seconds, so what I'm going to do first is just convert this 2.2 minutes into seconds. So 2.2 times 60 is 132 seconds. That means there's 132 seconds in 2.2 minutes. And then I'm going to divide that number by the 11 to figure out how many times a half-life actually occurs in 132 seconds. So 132 divided by 11 is 12. That means my T is going to be equal to 12 in this problem. The starting amount is still 40 grams, so we're going to say A equals 40 times 0.5 raised to the 12th power. Again, since we said there are 12 half-lives in 2.2 minutes. And then you're just doing 0.5 times 12, 0.5 to the 12th power times 40. And again, it says round to the nearest hundredth. So when you do that with a calculator, it's approximately 1/100th of a gram, or 0.01 grams. Okay, we're going to try some problems now on a Google form. Please, if you have any questions at all, just comment and let me know. And have a great day.